Physics has a reputation, one that precedes it in every classroom. Even people who did well in school will say, almost with a haunted look, that physics was the class that humbled them. Chemistry annoyed them. History buried them in reading. Calculus bruised them. Physics, though, made them feel stupid in a more intimate way. It did not merely ask for memory. It did not merely ask for procedure. It asked for a different relationship with reality itself. That is why physics is so difficult. It is difficult partly because it demands several kinds of intelligence at once. Most subjects let you lean on one strength and drag the rest of yourself across the finish line. In history, a good memory can carry you far. In literature, verbal sensitivity can rescue you. In algebra, pattern recognition can do a lot of the lifting. Physics is greedier. It wants verbal understanding, mathematical skill, spatial reasoning, abstraction, and the ability to keep calm when the symbols start breeding on the page like rabbits in spring. That alone would be enough to make it hard. But physics has another nasty habit. It asks you to believe things that do not feel true. A heavy object and a light object fall at the same rate in a vacuum. Time changes depending on motion and gravity. Light behaves like a wave and a particle. Solid matter is mostly empty space. An object can move forever unless something stops it. An object can move forever unless something stops it. That last one sounds simple, yet it collides headfirst with daily life. In daily life, things stop. They stop because floors are rude, air is nosy, and friction never misses a chance to interfere. Physics begins by telling you that your ordinary experience is full of noise. That is a rude way to start a subject. The beginner thinks physics is about objects, balls, ramps, pulleys, planets, circuits. That is the bait. Physics is really about models. It takes the world, strips away the clutter, and replaces the messy thing with a cleaner version that can be studied. No air resistance, no rolling friction, no heat loss, no deformed surfaces, no weird asymmetry, no chaos from tiny imperfections. The world you live in is a house with crumbs on the floor, a leaking pipe, and someone yelling in the next room. The world of introductory physics is the same house after a very stern butler has cleared the table and locked everyone outside. Students often stumble here because they think the simplification is cheating. It is not cheating. It is the whole method. Physics becomes possible because it does not begin with the whole world at once. It begins with a simplified slice of the world. Then, once that slice is understood, it adds complications back in. First, the ideal spring. Then the damped spring. First the point mass, then the extended body. First the frictionless surface, then the real one. First the isolated system, then the system that leaks energy like a cheap bucket. That movement from simple to real is elegant. It is also hard because many students want the real situation first. They want the answer to the messy case they can picture. They want life before form. Physics insists on form before life. It says, in effect, that if you cannot understand the clean case, the dirty case will eat you alive. And physics is right about that. Another reason physics is difficult is that it punishes shallow understanding with particular cruelty. In some subjects, you can survive by memorizing formulas or repeating phrases that sound educated enough to scare off the weak. Physics has a different temperament. If you memorize an equation without understanding what it means, physics will wait patiently, and then hit you with a problem that looks slightly different from the homework. Suddenly, the formula you adored becomes a decorative paperweight. This is where students begin bargaining with heaven. They say, I studied, and they did study, often sincerely. But physics does not care whether you looked at the page for 4 hours while internally playing funeral music. It cares whether you understood the relationships. What changes? What stays fixed? What can be ignored? What frame of reference you are using? What assumptions are built into the model? A student who knows one equation deeply will often outperform a student who memorized 20, like a man stuffing canned food into a bunker. Physics also demands comfort with symbols, and symbols frighten people for a reason. A sentence feels stable. A sentence unfolds in time and gives your mind little handles to grab. Symbols do not offer that kindness. They sit there, like aristocrats at dinner, expecting you to know the rules without explanation. A Greek letter appears, a subscript appears, a vector arrow appears. Suddenly, the page looks less like knowledge and more like somebody's private grudge. And yet those symbols are doing useful work. They compress thought. They allow generality. They let one relation describe 1,000 situations. To read physics fluently, you have to stop seeing equations as cryptic decorations and start seeing them as sentences about reality. Not dead sentences either, living ones. A good equation tells you what depends on what. What happens if one quantity doubles? What vanishes in a special case? What symmetry is hiding under the surface? An equation is often smarter than the paragraph next to it, which is a marvelous thing, unless you are the one trying to learn it on 3 hours of sleep. Then there is the matter of scale. Physics ranges from the unimaginably small to the unimaginably large. At one end, you have quarks, electrons, quantum fields, and particles that sound like rejected comic book villains. At the other end, you have stars, galaxies, black holes, dark matter, and the expansion of the universe itself. In between, you have everyday matter. Fluids, motion, heat, light, sound, electricity, materials, and waves. In between, you have everyday matter. Fluids, motion, heat, light, sound, electricity, materials, and waves. Mechanics asks for clean reasoning about motion and force. Electricity and magnetism ask you to think about invisible fields that still produce measurable effects. Thermodynamics asks you to connect microscopic disorder with macroscopic rules. Quantum mechanics asks you to stop demanding that nature behave in ways that flatter your common sense. Relativity asks you to accept that your intuitions about space and time were, to put it kindly, provincial. Each branch has its own style of pain. Another reason physics is difficult is that it reveals the difference between seeing and understanding. We are visual creatures. We trust what can be pictured. Physics often operates beyond that comfort zone. You can picture a falling ball. Fine. Can you picture curved space-time? Can you picture a wave function? Can you picture a 4-dimensional space-time interval? People say they want to understand the universe. Then the universe declines to be theatrical enough for their liking. That is not the universe's fault. It also does not help that physics is cumulative. If you are shaky on algebra, the difficulty compounds. If trigonometry feels slippery, vectors become a swamp. If calculus is weak, motion and fields become much harder. If your grasp of basic concepts is foggy, advanced topics become a house built on wet bread. This is one reason physics creates despair so quickly. Students often think the current chapter is the problem, when the real problem is that 3 older cracks in the foundation have finally joined hands. The subject is merciless about prerequisites. Still, the hardest part may be psychological. Physics is full of delayed understanding. You can sit with an idea for days and feel nothing. Then suddenly, while washing dishes or staring at a parking lot, it clicks. That delay is maddening. In many areas of life, effort produces quick signs of reward. In physics, you can work honestly and still feel lost for a long stretch. This makes people think they are failing when they are often in the middle of the actual learning process. Understanding in physics does not always arrive politely. It lurks. It circles. It shows up late and acts as though it had been invited all along. That lag crushes people who are used to immediate competence. And physics is very good at injuring vanity. A bright student can coast through years of schooling by being verbally quick, good at memorization, or generally slick in the classroom. Physics is one of the first places where that strategy can break down. The student who is always the smartest person in the room suddenly meets a problem that does not care about charm, speed, or self-esteem. This is healthy, though it feels less healthy at the time. Physics exposes the difference between performing intelligence and exercising it. There are few spectacles stranger than a talented young person discovering that nature will not be bullied. Nature is old money. It is not impressed. There is also a cultural problem. Physics is often taught badly. That is not the whole story, but it matters. Too many courses turn physics into equation shuffling before students have built intuition. Too many students are taught to hunt for formulas instead of asking what kind of situation they are in. Too many instructors move as though confusion were a moral failing, instead of the ordinary condition of beginners. A good teacher makes the abstractions feel earned. A bad one makes the subject feel like a wall covered in symbols and quiet disappointment. Still, even with perfect teaching, physics would remain difficult because reality itself is difficult. That is worth saying clearly. Physics is hard because the world is not arranged for our convenience. Human beings evolved to throw rocks, notice faces, judge distance, fear snakes, gossip, and find berries. We did not evolve to derive Maxwell's equations, interpret tensor notation, or keep track of inertial frames. The wonder is not that physics feels unnatural. The wonder is that creatures like us can do it at all. A primate on a dusty rock figured out the age of stars, the behavior of atoms, the bending of light, and the mathematics of motion. That should inspire a little humility and a little awe. Instead, many people settle for saying, "I'm bad at physics," as though that were the end of the matter. Usually it means they met something worthy of effort. Physics trains a kind of honesty. It teaches you to separate what you assume from what you know. It forces you to define terms, identify variables, state conditions, and follow consequences, whether you like them or not. It teaches patience with abstraction. It teaches respect for order. It teaches the mind to move from appearance to structure. Those are not small gains. They affect how you think far beyond the classroom. This is why people who have really studied physics often sound different. Even when they are wrong in an organized way. They have spent years learning that every claim has conditions, every model has limits, and every quantity has a relation to others. They have learned that intuition is useful, but not sovereign. They have learned that elegant ideas still need proof. They have learned that reality keeps receipts. So why is physics so difficult? Because it asks too much at once. It asks for mathematical discipline and conceptual clarity. It asks you to distrust raw appearance without drifting into fantasy. It asks you to treat symbols as meaning. It asks you to build understanding in layers. It asks you to accept that the universe is stranger than your first impressions. It asks for patience when comprehension comes slowly. It asks for humility from the gifted and endurance from the discouraged. In return, it offers one of the deepest pleasures available to the human mind. The moment when a physical principle finally clicks is a rare kind of delight. The world becomes sharper. Motion looks different. Light looks different. The sky looks different. Even ordinary objects begin to carry a hush of hidden order. A swinging lamp is no longer merely a lamp. A rainbow is no longer merely pretty. A hot stove is no longer merely regrettable. Things acquire depth. The world stops being a pile of surfaces and starts revealing its frame. That is why physics is difficult, and that is why it is worth the trouble. Because every hard-won piece of it lets you see a little farther into the greatness of things.